guys, hi, welcome back. So in this video, we will discuss the questions of GSET 2022. So we'll discuss physical science questions. So you can consider this as part one. So we'll discuss the detailed solution of all the questions. Okay. So here the first question is, what is the directional derivative of phi as a function of x, y, z? And it's given to us phi is equals to x square yz plus 4xz square at 1 minus 2 1 in the direction of 2 I cap minus j cap minus 2 k cap. So this is quite simple question. So first what you will do to find the directional derivative. Okay, what you are doing, you are taking the gradient, right? What you will do, you will take the gradient of phi. So gradient of phi means what? You will just differentiate first, you differentiate del x with respect to what? X square yz plus 4xz square, because you are having x in both first term and second term. Next again del y of the same term x square yz. In the second term there is no y, so I'm not writing it because it will be 0 plus del z of what? X square yz plus you will have 4xz square. Clear? Just do the differentiation first. You'll just do the differentiation and calculate the unit vector of this particular vector equation given to you. Okay, just you will do what? Del phi, and you can take this vector to be a, so unit vector of this vector to be a. Okay, sorry, you will take it as a. Just a second, I'm cancelling it. You will just write the gradient of this into with the unit vector. Here a is the unit vector of the vector given to you. Okay, so this is how you will do. So first let us calculate the gradient. So del phi is equals to, if you differentiate, you will get yz is constant, so you will get 2x and yz plus here you will get 4z square, right? And here you will write here I cap, here there will be a j cap, and here it will be a k cap. So this is what? I cap. Okay, now here if you see del y, so it is plus x square z j cap. And the last one is what? X square y, right? Plus 8xz. This is what? K cap. All right. Till here it's clear. Now you just put the values of, this is the value of x, this is the value of y, and this is the value of z. You'll just put in this. Then what you will get? Del phi is equals to, for this one, when you will put the values, x, y, z is what? Just minus 2, right? This is plus 4, z is 1, so it is plus 4. This is I cap, right? Again, next, if you see for the j cap, this is the j cap x square z. So x square is what? 1. Z is what? You can just see 1. So it is 1 into with 1, just there will be just j cap. Okay, this is just j cap. And the last one, what you will write? X square y. This is x square y is what? Minus 2, right? This is minus 2 plus 8xz, which is plus 8. Clear? Here you will have the k cap. So finally, what you will have? Del phi is equals to, this is minus 4 plus 4. So this term will be what? 0. Here you will have j cap with a positive sign. This is minus, right? This is how you will write. This is not minus, this is plus. Okay, you can just see. So this will be what? Plus 6 k cap. All right, this is what you are having. 8 minus 2 is 6. Now just you will do what? Del phi into with a, the unit vector of this particular vector. So del phi is what? J cap plus 6 k cap. You know the formula of unit vector is what? Magnitude of the vector. In the numerator, you will have the vector. You can write the unit vector as any unit vector n cap is what? The vector n by its magnitude. Okay. So here you will write the vector is what? 2 I cap minus j cap minus 2 k cap. And in the denominator, what you will have? 2 square is 4 plus 1 plus again 2 square is 4. Clear? So I cap is 0. This will give you what? Minus 1, right? And this side, what you will get? Minus a plus a is what? Minus 6 to z is what? 12. Clear? You know dot product of j and j is 1, k and k is 1. And this will give you what? Root over 9. So finally it is minus 13 by 3. So this is the directional derivative. So the correct option is option B, minus 13 by 3. For the second, if you see, if A is such that the curl of A is equals to 0, then A is called, this is a direct question. This is called irrotational. Okay. Now the product PQ of two real symmetric matrices P and Q is what? Symmetric for all P and Q? No, never symmetric. The correct option is option C, symmetric if PQ is equals to QP. It is also written PQ inverse is equals to Q inverse P. This way also you can write it. Okay. First Q symmetric and all those things. But now you can just see, because you are just asked the product of PQ of two real symmetric matrices is what? Forward condition. So you can write symmetric if PQ is equals to QP. Next is for Levi-Civita tensor, we have what? So this is also quite easy. You can write just epsilon ijk is equals to minus epsilon jik, because it is ijk. It is here what? Ij, so a negative sign will come. Okay, the variables are what? Changing. So just put down negative sign here. Clear? So now let us see question 5. So here what it is said, which of the following gives the solution of the differential equation what? K1 dx dt plus K2 x K3, where K1, K2, K3 are the positive constant with an initial condition x is equals to 0 at K equals to 0. So this is very easy. What you will write is, first here it is given K1 dx dt plus K2 x is equals to what? K3, right? So directly, just first we will do the solving part. Okay, so this will give you K1 dx dt is equals to what? K3 minus K2 x. And further you can write it as what? This one when you will write, you will just write it as dx. This term you will bring to the left hand side, which is K3 minus K2x, which is equals to 1 by K1 dt. All right, now you will take this denominator to be u. So what I will write here is, let K3 minus K2 x is equals to what? U. When you will differentiate this equation, what you will get? This is the constant term, so it's 0. This is minus K2 dx is equals to what? Du. All right. This is what you're having. And from here, what you will write in this particular case, dx is equals to what? Dx is equals to minus 1 by K2 du. Just put the values in this equation 1. Okay. Here, when you will put this dx is what? Dx can be written as minus 1 by K2, right? This is the numerator, which is written as, taken as u, so it is 1 by u. And here you will have what? Du, obviously. And in the right hand side, this was what? 1 by K1 dt. All right. So keep it just simple. And directly you can do it when you will do the integration part. This is constant 1 by K2. This will give you what? When you will integrate, you will get this to be what? ln u. This is 1 by K1 t plus c. Okay. This is what you will have. And finally, you can write minus 1 by K2. You will take this to the right hand side. I'm taking here only in this step. This is ln K3 minus K2 x. And this will go to the right hand side and you will have what? Minus K2 by K1. Okay. And plus take this as constant C1 or whatever it is. Because K is also a constant. So finally from here, what you will get from this conclusion, okay, what conclusion you will get from here? You are having the condition what? At x is equals to 0, t is equals to 0. And this is having a t, okay, don't forget to write. So this term will be 0, this term will be 0, and you will get the constant C1 to be equals to what? So C1 will be equals to ln K3. Therefore, this equation can be written as ln K3 minus K2x is equals to minus K2 by K1 t plus ln K3. Now bring this ln K3 to the left hand side and you will have what? ln K3 and K3 with cancel at 1 minus K2 by K3x. And it is equals to minus K2 by K1 t. And there is a constant. There was a constant, right? So that constant, you can just forget it for the timing. Okay. Just write it as ln K3. Now what you will see in this particular case, that when you will remove the ln, what you will write? 1 minus K2 by K3 x. It is equals to what? A to the power, right? A to the power of this. I think this is the basic logarithm called calculation, which you can do on your own. So this is what? T. This is what you will write. Yes or no? E to the power. This is what? 1 minus k2 by k3 x a to the power minus k2 by k1 t. So from here, what you will write? X is equals to what? This will go to the other side. So it will be positive. So it will become what? Negative. And this minus will go. Just take it this way. I'm taking this. So it will be minus. Again, minus if I multiply. So it will become plus. So 1 minus a to the power minus k2 by k1. This is t. All right. And here, this term will go again here. So it will be k3 by k1. So now you will take at t tends to infinity. So when t will be tending to infinity, what you will have? X is equals to what? T tends to infinity. So this will give you 1 minus 0. So x is equals to what? K3 by k1. Okay, so this is constant. The value is constant. And at what? The other condition where at t tends to 0. T is 0. So this x will be what? T tends to 0, x is equals to 0. Right. So the curve will what? Either the curve is a constant or there is a variation. Right. So from here you can see there is a variation of t in this way. So the correct option is option 5. Clear? Next we will see question number 6. For which of the following conditions does the integration 0 to 1 pmx dx vanish for m not equals to n, where pmx and pnx, these are the legendary polynomials of order m and n respectively. So if you remember and if you have studied a bit, then you can directly write that m minus n is a non-zero even integer only. This is how you can write. So if you want to see the calculation for legendary poly, it is -1 to 1, right? Here it is pmx, and this side you are having what? pnx, okay, which is equals to what? 2 by 2x plus 1. And here you are having Kronecker delta mn, okay? So when you will do in this particular case, when you will do so, you can just -1 to +1. So integration, you can make 0 to 1, put a 2 outside. Again, this is pmx, this is pnx, right? In the right hand side, everything is same, 2x plus 1, Kronecker delta mn. Now you see, when pmx and pnx, this can be done only when this pnx and pmx, these are even. So if you see in this case, pmx and pnx are even, only even. For even only, you can just change the limit, right? So if you take here m, okay, this is 0, 1, 2, 3, 4. This, so 0 is what? This is for even. Then you will get what? Odd. Again, you will get even. Again, you will, for 3, you will get what? Odd. And for 4, you will get what? Even. That means what? M minus n. M minus n must be what? Non-zero even integer. It's only then you will get this particular value to be what? Even. And remember that m is not equals to n. Okay? M is not equals to m, and Kronecker delta mn is equals to 0. This is what? So correct option is option C. Seventh, if fz is analytic and has a pole of order m as z equals to a, then 1 by fz has what? So this is very simple. It is a 0 of order m at z equals to a. Now the coefficient of e to the power ix, okay, e to the power ix in the Fourier expansion of ux is equals to a sine square alpha x for k is equals to -2 alpha is. So it's very simple. You're having what? Sine square alpha x, right? So directly you can just write it. This is a x can be written as e to the power alpha x minus e to the power minus I alpha x by what? So what you will write in this particular case, this is 2 square, so it's 4. So minus a by 4. This is e to the power 2 iota alpha x minus e to the power minus 2 iota alpha x. This is what you are having here. Okay. Just take the condition k is equals to what? Minus 2 alpha. So alpha is equals to what? Minus k by 2. Right? This is what you're having. Therefore, you write here minus a by 4 e to the power. This is what? 2i, okay, x. Alpha is what? Minus k by 2 minus e to the power minus 2i x. So here also it is what, minus k by 2. Clear? This is what you will have. Is it done? And again you will have your minus 2. You can just check it out and see. Okay, then from here minus a by 4, this will give you what, this 2 and this 2 will get cancelled, e to the minus I kx minus, this is e to the power, this is a minus 2 here. Okay, this 2 and this 2 will get cancelled, and this is minus a plus, so e to the power I kx. Clear? And here you will have a 2. This is positive. Okay, so from here e to the power ix, the answer is a by 2 with a positive sign. Clear? It is plus a by 2. You can just see coefficient is just right. So it is plus. This is not minus. This is plus a by 2. Option C. Clear? Inverse Laplace transform of what? S plus 1 by s square minus 4. So you will just have to do the inverse Laplace transform. So as for I remember the previous year question of gate, if I'm not wrong, I'll just see and then tell you. Actually, I remember this was a question because I have seen and I have solved a lot of questions. So I found this question there. So many of the students, if they have attempted, then they can directly write the answer to be option D. Okay, for those who have not checked these questions, they will have to do it. Okay, so this is a question, direct question from GATE or CSI NET, any one of the examination. Okay, and if I remember, you can just check it. It's a GATE 2007. Just check it out. Okay, now we will see this question, how we will solve this question. So for this, you will just write the function fs is equals to what? S plus 1 by s square minus 4. Clear? So this is what you're having. So which is equals to what? I think you can write s by s square minus 4 plus 1 by s square minus 4. This is how you can take. Now Laplace inverse of what? F of s. How you will write? Inverse of what? S by s square minus 4 plus L inverse of what? 1 by s square minus 4. So now it's quite easy for you can write it right. For s by s square minus 4, it is what? Obviously cos 2x. Okay, because this is what? 4. So it is 2x plus here what you will have? For this you will have 1 by 2, right? This is 1 by s square minus 4. So it is obviously sine hyperbolic 2x. Okay, this, just a second. This is also cos hyperbolic. Remember, this is also cos hyperbolic. So the correct option is option D. Now for this, what it is given to you in this particular, the inverse Laplace transform of s square by s square plus 4. So for this directly you can write, if you remember, this is for log. Okay, you will just do D. For this I'm just writing DDS you will do. Okay, this is for ln. Okay, ln, this is s square minus ln, how much it is? S square plus 4. This is how you will write. Okay, and just from here, this will give you minus 1 by 2. And when you will differentiate this, you will get 1 by s square. Numerator will have 2s minus 1 by s square plus 4. This is also 2s. Okay, and from here directly what you can write is, you can take minus 2, means 2 common. This s and s will get cancelled, so you will get minus plus 1 by s, and here if you see it is s by s square plus 4. So this is what you are having, and from here directly you can write for 1 by s and s by s square plus 4. If you take cos, you will have to take what? Minus 2 by t. This is cos of what? Cos of 0, because this is nothing but s something plus, it is actually in the form of what? S square plus a and s square plus b. So here it is nothing, that means it's 0. So cos 0 minus this is cos of what? 2t, right? Cos 0 is your 1, so minus 2 by t. So it will give you 1 minus this is cos of 2t. Clear? This is how you can write. So it is minus 2 by t, 1 minus cos 2t. So for this j minus half jx is given. This is directly option D, root over 2 pi x by cos x. But if it would be plus 1 by 2, then it would be sine. Clear? And question number 12, it's quite dicey for me, but I think option A is the correct option. Most likely this is the correct option for 3 by 8 rule. So that's all in this video. Thank you so much. I hope that this would have helped you. Good luck.